Okay, so this next video is going to have a lot of definitions, a lot of information, but remember that this whole class is open book, so you can just kind of use this as a resource, look it up whenever you need to, and we're going to talk about sampling methods. So again, censuses, sense-I, are really, really nice, when they're possible. But the fact of the matter is, a lot of times we can't survey the entire population. We have to survey a sample. So how do we choose which people or things get surveyed? That's by sampling methods. And there are different ways of doing it. So we're going to start, because one of the main things that we're going to be keeping in mind, and what I always want you to be keeping in mind outside of this class, whenever anyone's talking about statistics in any sense, something that you want to think about is bias. Specifically here, we're going to talk about sampling bias. And in 8.4 or 5, we'll talk about other kinds of bias as well. The sampling bias occurs if every member of the population doesn't have an equal likelihood of being in the sample. Okay, so, if we want to, if we're going back to where we're going to poll everyone in college, we're going to poll everyone at SPSCC about their textbook costs. But if we only sample the people from my classes, then that's not going to be a representative of the population. And certainly, it's deterministic, it's not random. Every member of the population does not have an equal likelihood of being in this sample, because every member of the population doesn't have an equal likelihood of being in my class. Okay, so that would maybe be a silly way to sample if we care about that population. Anyway, so sample 8.5, in 1936, the Literary Digest conducted a poll by mailing questionnaires based on its list of subscribers. Based on its results, the Literary Digest predicted Alfred M. Landon would win with 57% of the popular vote. However, Franklin D. Roosevelt won by 62% of the popular vote. What are some possible sampling biases that could have contributed to this study? All right, so this digest in 1936 did a poll by mailing these questionnaires to its subscribers. Okay, so the subscribers, are likely a very different group than the entire voting population. Like if we polled everyone, we polled like a bunch of people who watch like Fox News, and if we poll a bunch of people who watch CNN about an election, they're going to have very, very different voting information. Can't speak English today, but right? So, I don't know about the Literary Digest in 1936, but maybe that's what it was. Maybe there are certain politics. Maybe they're Landonites. Alfred M. Landon. What would the world have looked like if he won? Anyway, so that is a possible sampling bias. And also, it mailed the questionnaires, but not everyone got back. Right? Like, you didn't have to mail the questionnaire back to them. So maybe we have something that we're going to talk about in the next video of self-selection, right? The recipients chose whether to respond. And so, maybe the type of people who respond to these things are the type of people who like Alfred Landon. All right. That's another idea. There could be more. Okay. When each member of the population has an equal probability of being chosen, this is called a random sample. Equal probability, random sample. Random samples, a lot of times, are nice. If every member of the population and any group of members has an equal probability of being chosen, then it's called a simple random sample. Okay, so every member of population, equal probability, random sample. every member of the population and any group of members, simple random. So they almost are the same, right? Random sample and simple random sample are almost the same. Simple random has this, and there's a mathematical distinction here. We're not going to worry about the distinction. I'm not going to belabor it. I'm not going to quiz you on the difference necessarily, but we'll maybe kind of see this as we talk about other sampling methods. Okay, so let's look at an example. If we identify all likely voters in a state, say Washington, and we put all of their names on a piece of paper, it's a lot of pieces of paper, and we toss these slips into a very large hat, all these likely voters in Washington in this giant hat, and we draw 1,000 slips out of that hat. After shuffling it, we would have a simple random sample. Okay, this is, we like to think about this as true random sometimes. That's a very loaded word, but if things are completely random, a lot of times colloquially, that's enough to say it's simple random. And again, we'll contrast this with these other methods as we go on. So there's a note, when researchers need to select a large sample, like in this case, 1,000 slips out of a hat, you're probably not going to manually take 1,000 slips out of a hat. So when you need a really large sample, a lot of times we use statistical software. So maybe Minitab, SSPS, MS Excel is used sometimes as well. We can use those to select the subjects for a sample. All right, and there are other methods as well. Always change. So the natural variation of samples. Even if I use simple random sampling, like think smaller. Let's say the population is all of you guys in my class, and I sample 5 people out of my class. Well, every sample is going to be different, and so the data from each sample is always going to be different. And so that natural variation of samples is called sampling variability, and it's unavoidable, and a lot of times it's expected and not an issue. Okay, there are some cases where it could be an issue, but usually it's not. It's just what happens. It's random. So there's a lot of different ways of doing sampling, and we're going to do one more example, and then we'll talk about these other methods. So if we repeatedly take samples of 1,000 people from a population of likely voters from Washington state, some of these this is kind of what I was just saying. Some of these samples might have a different higher percentage of Democrats or Republicans than the actual amount in the general population. So we could get lucky or unlucky, depending on your point of view, but probably unlucky if you're a statistician, regardless. And your sample might just randomly be really skewed in some kind of metric. In this metric, it would be, political leanings. That can happen. So some samples might include more older people, some samples might have more younger people, etc. And this is another example of sampling variability. So some other methods right here. We'll go through these kind of quickly and then refer to them again as we're doing this example to kind of classify which method is being used here. The stratified sampling kind of guarantees that you get representation. Like, let's look at this example, 8.7, right? It's theoretically possible that if we do a simple random, names from a hat, we get all Democrats or all Republicans. It's very unlikely with a sample size of 1,000, but it's possible. Whereas in stratified sampling, a population is divided into some subgroups, and then we randomly sample each subgroup with a sample size proportional to the size of that subgroup. So, if we didn't want the super unlikely case of, different number of Republicans and Democrats, maybe we say, okay, Washington state has 50-something% Democrats, and I don't know the proportion, but you could split it up into those, and then those could be your strata or subgroups. Could be done by age. And then within each group, we're going to randomly sample from that group, so that can ensure that we have that representation if that's something that we care about. Not to be confused with cluster sampling. We're going to skip one, because cluster sampling is also divided into groups or clusters, but there's a difference. In Stratified, we divide into groups in both ones. In Stratified, we do simple random sampling from each group, whereas in cluster, we choose some subgroups and do everyone in those groups. So simple or stratified is a little from every group. Cluster is all from some group. So don't get those confused, because they both involve groups. Quota sampling is a variation on stratified sampling. It's very similar, wherein samples are collected in each subgroup until the desired quota is met. Okay, so maybe, you know, there's a certain number of Republicans or Democrats that we want to sample. Systematic sampling is every nth member of the population. So maybe you have a list of people and you just pick a random start, and then you say, we're going to sample every 5th person on this list. That's what it means, every nth. Every 5th person, every 4th person, every 17th person, etc. Convenient sampling is not the gold standard. It is samples chosen by selecting whoever's convenient. So if I am curious about, you know, students at SPSCC and their experience, convenient sampling would be asking you guys, because I already interact with you. A lot of times it's convenient, but not representative of the whole population. Another bad one is voluntary response sampling. Kind of mentioned that a little bit above, where you allow the person to volunteer, like mailing back in a questionnaire to a 1930s. Ow, keep hitting my finger on the desk. Like mailing a questionnaire and having people either ignore it or mail it back. Or maybe you have an advertisement on the wall and it has one of those little tabs, and you pick off a tab and call the number or whatever. That's voluntary response sampling, and that has its own bias. So this video is getting a little long because there's a lot of definitions, but let's wrap it up with this last example. Every 4th person in the class was selected. So, you know, we go off in a class and I say 1, 2, 3, 4, 1, 2, 3, 4, and then I say all the 3s. That would be systematic. Sample was selected to contain 25 men and 35 women. That's going to be quota. Samples are collected in each subgroup until the desired quota is met. We need 25 men and 35 women, so quota. Viewers of a new TV show are asked to vote via the TV show's website. That's voluntary response. They're told to vote, and the people who are likely to vote are the people who probably feel very strongly about something, and usually angry. Usually the naysayers are louder than the happy people. A website randomly selects 50 customers to send a satisfaction survey. So it does seem kind of like simple random, right? The website is randomly selecting 50 customers, but they also have to accept it, right? So it's kind of also just, and it kind of depends on like what our population is. I don't think this one's entirely clear, but it's like partially simple random, but it's also voluntary response. There's a lot of there's flexibility in some of these. And the last one is, we're curious about voters in a town. So this polling company is randomly selecting 10 city blocks, and it interviews everyone on those blocks. Okay. So there are groups. The groups is what block do you live on? And we're choosing everyone in those chosen groups. That's going to be cluster sampling. Okay. So you can ask me more questions on this. We got some in the homework, but if you're curious about any of this, reach out to me. Believe it or not, I like talking about math and statistics. Anyway, enjoy the homework. Enjoy it. If you don't enjoy the homework, you're doing it wrong. Well, that's maybe a strong statement. Bye-bye.